Welcome back everyone to the Hello World Guide. This is the first episode, actually not the first episode, the 11th episode to be precise of our 3D render series. We did this series a while back and I decided that we should probably continue this and implement some of the stuff that we didn't, because we could expand this 3D render in a lot of different ways and we could probably keep doing that. So we'll start by implementing some things to make our 3D renderer better. So this is actually the 11th episode of this series. So in order to begin, what we'll do is we'll just start by kind of getting a recap of what we had in the previous when we did the series earlier. And you can see that what we had was pretty simple. We basically had like a thing that can read the 3D models from the file and can open it up and display it, and everything kind of works. You can move around with the camera and you can see that it does render 3D objects like they are supposed to be rendered. However, there is currently no lighting and shading, and currently what we have got on our scene screen here is known as flat shading, because everything is shaded with a single color, and that does not look very 3D. Actually it looks kind of boring. So in order to make this more interesting, we'll need to add some lighting and shading to this, and in order to do that, what we'll do is, let me just close this down. We'll use we won't actually go ahead and use like a physically based render or something like that, because that would be too complicated and completely out of the scope of this series. Perhaps you could do that sometime later as well, but in order to begin, you should always, in order to get a good understanding of how light works, if this is your first time in 3D graphics, you should start with learning the Phong model that has been used, it's not really used in actual games or apps these days, but it's still used in some different view modes, just for testing some representations of object, and it's good for a beginner. You can kind of learn a lot of stuff from it, and it's not too complicated to implement. So in order to get started with Phong, we will actually get started with the actual lighting part in the next video. In this video we actually need to make some preparation. So if I go here in my model class, you can see that we are reading the meshes, and in the meshes we are basically reading all of the vectors, the vertices which are stored as GLM vectors, and we are also loading all of the meshes here as well, by learning the faces of the actual object. So what we are going to do is we are going to open up if I open up this mesh, AI mesh actual structure, in the header file mesh.h, you can see that it contains a number of vertices, faces, like an array of vertices, and also it contains vertices and faces, of course, but it also consists of some other ones like normals, tangents, and bitangents. These store different kinds of data. So what we don't really care about these for now. We will perhaps need them in more advanced stuff, but for our basic Phong lighting model we only need this normals. Currently we are reading only the vertices, but we also need to read the normals. You can see you can read this to understand that this all of these array consists of normalized vectors, but that means that all of the vectors are it's basically has its length set to 1, and you can see that this normals is basically like an array, and we can read the normals from it. However, there is not a number of normals, because the number of normals is equal to the number of vertices. We need to store these normals as inside of our own structure here, because we will need these normals in the actual lighting calculations. So in order to do that, we'll have to open up our mesh definition, and actually we'll need to change that. So I'll open up mesh.h here, and you can see we are basically storing vertices and an array of vector 3s. That is not what we are going to do anymore. Instead, what we'll do is we'll create a struct, and this will call Vertex. The reason we're creating this struct here is because we want this struct to be basically what's called to be trivially copyable, which means it won't contain any pointers, it won't contain any complicated objects, it won't contain any complicated functions or stuff of that sort, but it will contain basic types. So what we'll have it contain is a vector 3 called position, because each vertex quite obviously has a position, and another thing that we'll have it contain is a vector 3 called normal. So we can create normal here, and perhaps we can actually have it be full position. So these are two vector 3s that we right now need in our vertex. We don't need anything else for now. So what we'll do is we'll make it that way, and we'll change our definition of mesh here to have this be a vector of vertices instead of just being of a vector of 3D vectors. So we'll go ahead and have it be that as well in the constructor, and that will allow us to initialize it quite easily. We'll need to of course change this so that it also takes in the correct type here, and you can see it says that transformation is uninitialized. You can just initialize it here, transformation, like that. Yes, and you can see that here we have got everything, but that we'll have to actually change some of the stuff that we have got here. You can see we have got GL vertex attribute pointer, and we are using this to kind of point to one vertex like attribute, which is basically the position of the mesh. So this is, we will need to add another one of these attributes. So I'll just copy and paste this code again, and this you can see we are going to change this. The first argument, if you remember, should be the index. You can see it's basically the index. We'll need to change that to 1 because of course this is the next index, and we'll also activate the array at index 1. And this will also be similar because it's basically a vector, and we'll actually change this because you can see that currently we are passing a null pointer. It requires a void pointer. We'll cast it to a void pointer, and what we'll cast is we'll use a special operator called offset of. What that does is that it returns the actual offset of a particular element from a particular vertex, for like a structure or something of that sort. So what we'll do is we'll pass in the vertex here first of all, like that, and then what we'll do is we'll pass in our position here. So we'll just copy that position from here and we'll pass in here, and let me just move it to the next line so that we can see it a bit better. And this is what we'll do is this will give us the actual offset of the position from the vertex, and this is going to be 0 because the position is just at the start of the vertex. And the next thing that we'll do is we'll give it the normal, and this way the way we are doing this here is much better and much less error prone than having computing the actual points normally, because that could be quite bad actually. If we were to like change something, or like even Visual Studio decided to pack our structure differently, this could get wrong. However, this way we ensure that it automatically calculates the correct offset, and we can use it correctly. So after that, there's not much else that we need to change here inside of the mesh class, but we do need to change our model, because currently you can see we are initializing it with that. That won't work anymore. So what we'll need to do is we'll need to have it be a vector, like an vector or vector. Basically this vector, sorry, vertex. So it will basically be a vector of vertices called vertices. And what we'll do is we won't push back directly. Instead what we'll do is we'll create a vertex called vertex, just like a temporary vertex to kind of store stuff here. And what we'll do is we'll basically go ahead and when we are taking this thing here, we'll not push it back into vertices directly, but instead say vertex dot position, and we'll set that position to whatever we have got here. So we'll cut this value and paste it in here. Now that works for the position, and we'll do a similar thing for the normal. First of all, what I'm going to do is I'm going to go under like here and actually push back the vertex that we have got. And another thing, of course we want to store the normals here as well. So what we'll do is we'll basically copy and paste this. The reason we are doing this again is I'm going to label this as the position, so I'll just rename this to position, and I'm going to rename this to be our normal, so like that. And we'll basically copy and paste this line of code and change it so that we take from our normal instead here. And of course there's another thing that we need to do. First of all, let's handle the normal here. So we'll pass normal dot x, y and z to the glm vector constructor here, and for the actual attribute we'll also set the vertex dot normal. And after that, the next thing we need to do is we need to make sure we get this from m normals instead of m vertices. And that is pretty much all we need to do to read the normals correctly. It's pretty simple, and we can just push that back in our vertex here. Now the other thing that we need to change is inside of our shaders. So I'll go in here, I've got shader files here, I'll open up my fragment and vertex as well. In vertex you can see we are only taking in one thing currently, we'll need to take in another. That other thing is also going to be like a vector 3, but it's going to be called the normal, and its location is going to be 1. As you remember, we set the index to be 1 in the mesh class. So that we have got here, and currently there is not much we are doing inside of here, because we are basically setting the position to this, and normal is not being used. But what we'll do is, inside of vector color, like fragment.glsl, we'll take we'll take like an in variable that we'll get from the vertex shader, and this would be a vector 3, and we'll call this normal with a capital N this time. And what this would help us do is, it will get the normal, because the place we need the normal is inside of the fragment shader mainly. So we'll copy that normal, and we'll go in here, and what we'll do is, we'll set the GL position to this, and you might say, let's just set the normal directly to that normal variable that we have got here. We can just set it to that, like that. Now for this video we are just going to wrap it up here, and in the next video we'll actually start implementing the different algorithms and techniques to like the formulas to implement different kinds of lighting effects and shading effects inside of our 3D renderer here. So stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and bye.